So our project is called Melatect, and it is a machine learning approach for identifying malignant melanoma in skin growths. And this was done with our mentors, Mr. Allen and Joyjeet Majumdar.
So the main components of our project is our app, and we have an iOS app that is ready to publish, and we also have an Android app that is going to be published pretty soon. And we also have our ML model, which can detect skin cancer from a picture. We are working on making a website for our app, and we also have a lot of biomedical research, including our research paper, statistical analysis, and annotated bibliography.
So our app consists of two interfaces, the patient and clinical trials interface. The patient interface is meant for patients to use the app and get in contact with doctors, evaluate the risk they're at for melanoma using a set of predefined parameters in the risk assessment tool, and also get a classification on whether or not their mole could be at risk for melanoma. Our clinical trials interface is for the clinical trials that we plan to begin after our science fair actually ends, since we can't publish the app before science fair ends. And in the clinical trials interface, doctors and dermatologists are able to create entries of melanoma and moles that they deem malignant or benign, and then get a classification on them that gets sent to our backend, and we can use it to retrain our model.
This is just an interface of the upcoming Android version prototype. It has the same features that are in the iOS version, and we plan to publish this sometime in July, towards the end of July.
This is our, oh, sorry.
No, you can go.
This is our technical framework, and I don't think that we have time to go through all of the specifics, but the main components of this is just the two interfaces, so the clinical trials interface and the patient interface. And within the patient interface, the risk assessment tool and the melanoma identification view controller. And both of these branch out to outside resources, such as the National Cancer Institute calculator of what % risk you could be at for melanoma. And the melanoma identification tool reaches out to our machine learning model, which sends the image through the system and comes out with a classification on whether it is malignant or benign.
So when selecting our data set to train our model, we had two classes of interests, benign and malignant, and we got these images from the International Skin Imaging Collaboration plus various dermatologists that we reached out to, and we augmented these images to reach a data set of about 60K, and we used various tools for data augmentation. And some of the things that we did to augment the images is rotate them, saturate them, crop them, etc.
So part of our methodology was also the data augmentation that we did. So this is one of the novel features of our melanoma identification system. One of the reasons it's so hard for melanoma detection systems to be made accurately is because of the lack of data. So to go around this issue, we augmented our original data set of 20,000 images to over 60,000 images using AutoML libraries and other augmentation tools.
In terms of our website that we are going to make, we want to include information about HIPAA privacy laws and how we adhere with it. And it is just made with HTML, JS, and CSS. And in terms of our research, we have two research papers that one is technically oriented and one is biomedically oriented. And we have used about 45 sources and consulted with 5 dermatologists.
The accuracy of our melanoma detection model is at a 98.8% projected accuracy for images that we set aside for testing. This accuracy needs to be adjusted for the real life accuracy that it would have if this app was used on actual patients, and that's why we're running the clinical trials. So we used 10% of our original 20,000 image data set for testing, and these images were not used to train the model. We found that there was no bias towards age, sex, or anatomical site, but for dark skin, there is a slight issue, which is that dark-skinned individuals may have some problems using the model since there wasn't much dark skin data to train with, even with all the augmentation that we did. And the go around for this is that people with dark skin often develop carcinoma rather than like topical skin melanoma. So we haven't really done much research on that aspect of the project.
And we would just like to acknowledge the help that we received from a lot of people. Our physics teacher, Mr. Allen, helped us, and Joyjeet, who's also here today. He helped us a lot with our app development process, and he's still going to be helping us in the future. And we also have some dermatologists that we reached out to listed here.
Great. Thank you so much, you guys. It's really impressive, all the research that you put into this.